Here's a timeline of Ben Franklin's life. You can see that he was born in 1706. He died in 1790. The time moves in this timeline from left to right, and you can see some of his accomplishments, some of the events in his life. You guys did the same thing with your life. We can see born here, and this is someone who is about 15 and a couple months old. You can see when they moved to Rochester, when they started kindergarten, when they got their pet dog Ralphie and started high school. Again, we have time that's moving from left to right, and we can see different events, major events that happened in someone's life. We divide geologic time up the same way. If this represented the history of the Earth begins right here, and then over here would be right now. All the way to the right is 0 million years ago. All the way to the left is when the Earth begins at 4,600 million years ago. If you turn to page 99 in your notes, we have 4 main ideas that we need to get down. The first idea is that the Earth formed at the same time as the sun and the rest of the solar system. This happened, from what we just saw, 4,600 million years ago. We abbreviate million years ago MYA. So when you see MYA, that means million years ago. The Earth formed at the same time as the sun, planets, moons, asteroids, comets. Everything in our solar system formed at the same time. Just like Ben Franklin's life was divided up by major life events, and a student's life is divided up by major life events as well, the Earth's history is also divided up by major life events, like when the atmosphere first collects a certain amount of oxygen, the oldest rocks, the first life form, or the mass extinctions of different animals. Specifically, mostly when we talk about geologic time, we divide it up based on different events that have happened in life here on the Earth. A good example of a major event here on the Earth is when the dinosaurs became extinct. If the Earth started 4,600 million years ago, there's the beginning of the Earth. And here is today, 0 million years ago. Where do you think we should put this arrow for when the dinosaurs became extinct? Which letter would this arrow be closest to represent the time when the dinosaurs became extinct? So we know we divide geologic time up based on different events that have happened here on the Earth, usually related to life. We'll also look at some mountain buildings or things like when Pangea began to split up. But most of the time, we're going to split our geologic timeline up, the Earth's timeline up, based on major life events in the same way that you did yours. All right, let's go take a look at those dinosaurs. What letter did you put that next to? This is where it should be. So if we take a look at where the dinosaurs became extinct, it's right here. It's not at the letter P, it's actually beyond the letter P. It is much closer to right now when the dinosaurs became extinct than the beginning of the Earth. This is a super long geologic time. Remember, it's 4,600 million years ago. The dinosaurs only became extinct in the last recent. The dinosaurs only became extinct 65 million years ago. So if we talk about these extinctions, for example, the dinos, they became extinct 65 million years ago, compared to 4,600 for the start of the Earth. It's not that long ago the dinosaurs became extinct 65 million years ago. Let's jump over to page 98 of your notes, and let's start creating a timeline on here. So over on the left-hand side, there's 2 here. We're going to focus our attention here on the left. We're going to have this represent the Earth's time, geologic time. If you want to, you can turn it sideways, so it's very similar to what we just saw in the video. that it's going, that time is going from left to the right, I'm going to turn it this way. And so time is moving up. And this line down here, that'll represent the beginning of the Earth and, of course, the solar system as well. So let's label this down here. We know that this is going to be 4,600 million years ago. And that's the beginning of the Earth and the solar system. Now, there was no one day that the Earth began. It took a long process for our solar system to form, millions of years. But we'll start our Earth forming as a planet 4,600 million years ago. We're going to put certain events dealing with life, dealing with the Earth's history on this line. And then we'll get to this point right here, which is 0 million years ago. So everything over on this side of the line is measured in MYA, million years ago. And of course, that line represents right now, today. That line is today. 0 million years ago is right now. And here is where the Earth started. All right, go up 3 lines and draw 3 spaces. 1, 2, 3, and draw a line there. So we're going to have that line. That's actually the oldest rocks that we find on Earth, about 4,200 million years ago. It might seem odd. Why don't we find rocks that are older, right? There was an Earth here, so there's got to be some rocks there. Between weathering, erosion, subduction of plate tectonics, those rocks have been destroyed. They're no longer there. So the oldest rocks on the Earth are about this old. And when we look at those rocks, we don't really find any evidence of life until a little bit later. So if we can go up 8 lines, so there's 3, 4, 5, 6, 7, 8. Let's put another line here to represent our oldest fossils. This is about 3,500 million years ago. This is where our oldest fossils are. There's some evidence that there was probably life a little bit before that. And these oldest fossils, we're not talking about clam shells or dinosaur bones. We're talking about fossilized bacteria that we find in some ancient rocks. If we double this, instead of going up 8, let's go up another 8 for a total of 16. Let's put a line here because something really important to life happened around this time. About 2,200 million years ago. This is where we find abundant oxygen in the atmosphere. This allowed there to be ozone. Ozone is made out of oxygen. So if we have enough oxygen in the atmosphere, that'll create some ozone, which protects the life on Earth from ultraviolet rays from the sun. So now life could start existing on the Earth's surface instead of just in the oceans, which is what was going on for thousands of millions of years. With these oldest fossils, just a lot of bacteria, a lot of life just living in the oceans. Now that we've created enough oxygen, we can also have life that can live on the surface of the Earth as well. Life during all this time was very simple. It didn't get very complex at all. If we look at our notes, we can see that the earliest life on Earth occurred around 3,500 million years ago. That's true, but it was very simple for a long time. Bacteria, mostly one-celled critters. And then we had an event that happened about 542 million years ago. And that's pretty high up on the chart. So if we go here to up towards the top, so I'm going to go about 542 million years ago. Let's go down 4 spaces here. And draw a line there to represent when life started becoming complex. We refer to this time when life becomes more complex as the Cambrian explosion. There was no explosion. There was just very quickly, within a few million years, a large diversity of life on the earth. Most of the different groupings of animals that exist on the earth were started around this time. Life events that we talked about in our notes are appearances and extinctions too. Most life on Earth, most life that existed on Earth is now extinct. Most of the different types of critters that we see in the fossil record don't exist now. They become extinct. Not just the dinosaurs becoming extinct 65 million years ago, but other critters too. And they sometimes happen in mass extinctions where it was a lot of extinctions happening at one time. There was one of them that happened 251 million years ago. Let's put that about 2 lines down. There was a mass extinction. This is still well before the dinosaurs. At this event, something happened that killed a large number. Some people say up to 70% of all the species that lived on the earth. And we find them in the fossil record, but then we don't find them after here. An example of this might be the trilobites. We find trilobites in the fossils and these rocks of this age, but then we don't find any trilobites after that line. The other mass extinction, and the one that we started talking about, was the mass extinction of the dinosaurs. That happened 65 million years ago. That would show up on our chart about halfway. So let's put a line at the halfway point of this space. So 65 million years ago, we have another mass extinction. This is the one where the dinosaurs became extinct. There's a lot of events that happened during this time where life became more complicated. It's difficult to draw all of them in this small little space. So as geologists creating timelines, what we can do is we could take this small space and make it bigger. We're going to refer to everything that happened before the Cambrian explosion as the pre-Cambrian. So if I turn this sideways, everything that happened from the beginning of the Earth, from there, all the way to that Cambrian explosion, we're going to call the pre-Cambrian. So this whole time is the Precambrian. We're going to take this area right here and split this up into different life events. But to do that, it'd be a lot easier if we could take this and extend this out. That's why we have this other section over here. Watch what I'm going to do. I'm going to say anything that was in this area here, we're going to extend this to the same size over here. I'm going to draw a line from the Cambrian explosion down to the bottom of this other timeline. The now still stays the now. So here we have a timeline. Our starting timeline went from the beginning of the Earth, 4,600 million years ago, all the way to right now. This timeline is going to go from 542 million years ago to right now, 0 million years ago. Remember, we had in the Precambrian, very simple life. There's a great diversity of life in this area, and we'd like to put more information, but it's so small, it'd be easier if we made this a little bit bigger. we're going to take this time where there was a great diversity of life and split it up based on these mass extinctions. So we have 1, 2, 3 areas, 3 different eras of time that we're going to split this up into. The first one, let's count up 16 spaces and draw a line there. That's that first mass extinction, up 16 spaces. So that's equivalent to this mass extinction here. We'll put our numbers on there. This was 251 million years ago. And then the dinosaur extinction, we're going to go back here 3.5 spaces. So draw another line to represent the extinction of the dinosaurs back 3.5 spaces. And that's equivalent to this line over here. We have names for these different eras of time. Just as we call this the Precambrian, because this represents the Cambrian explosion right there, we're going to call this area the Paleozoic. So the Paleozoic time. Paleo means ancient, zoic means life. So this is a time of ancient life. And then we have this middle spot after the first mass extinction, before the second one. This is the Mesozoic. And then finally, we have this last section, meso meaning middle, middle life. And then recent life is Cenozoic, which has been the time since the dinosaurs became extinct 65 million years ago. Notice how short, compared to all of geologic time, notice how short the Paleozoic was. Notice how even smaller the Mesozoic was compared to the Cenozoic. There's so many life events that happened during this time. I wrote a bunch of them down. You don't have to write these down on here, but you can certainly see why we would take this area and enlarge it so we could fit all of that information. Imagine trying to take all of that writing and squeeze it into this small little area right here. It'd be difficult to do. Instead of writing all of this down, let's go to a place that has that information, and that's page 8 of the reference tables. On page 8 of the reference tables, you can see how we have 4,600 million years ago, the start of the Earth, moving to the right to 0 million years ago, right now. And we have a large section referred to as the Precambrian. This small section, which includes the Paleozoic, Mesozoic, and Cenozoic eras, is called the Phanerozoic Eon, and you can see how that's split up into the Paleozoic, Mesozoic, and Cenozoic eras. There's also eras broken up into different periods, and periods that are broken up into different epochs. On this page, just as we did on our page, this Paleozoic, Mesozoic, and Cenozoic eras, or the Phanerozoic Eon, is then enlarged so we can include more information. So here you can see that this area is then enlarged onto our page. So although the beginning of page 8 represents all of geologic time, once we move along page 8 and into page 9, we see that all of this information here is really just part of this one little Phanerozoic. So please be really careful if you're looking at something, let's say in this spot, that you don't look all the way over to the left. As soon as I get to this area, I need to follow these curved lines up. Eons are divided into eras, eras into periods, periods into epochs. There's a column here for life on Earth, where we can find rocks in New York State, different distributions of types of fossils, and specific information about index fossils, which are listed down at the bottom of pages 8 and 9. Geologic events that are pertinent to New York State, and then also the position of the land masses over time. We'll spend a little bit more time on this. And let's finish by talking about human existence. It's been very short as far as geologic time is concerned. 0.3 million years ago is when the first Homo sapiens arrived. Other hominid-like creatures were maybe 6 to 8 million years before, but even if we do that, compared to the extremely long time of the Earth, human existence on the Earth has been a very, very short time. So there are the notes on geologic time. We'll spend more time in class on how to read and use this chart.